be performing mathematical operations with two different functions. Okay? And so the first thing I want you to do is get familiar with the notation, because knowing what they want you to do is half the battle. Okay? So this is f of x plus g of x. So they obviously want you to add those two functions. Okay? They could ask you to add them like this, or they could say f plus g of x. I want you to get used to this notation. Both of those things are asking you to do the same thing. They want you to add whatever the f of x function is to the g of x function. In that case, all you're doing is combining your like terms. Okay? The next one is subtraction. If they say f of x minus g of x, you're going to substitute in whatever f of x is and subtract whatever g of x is. Okay? Or they could say f minus g of x. That's asking you to do the same thing. All right? This is asking you to multiply the two functions together. So in 99.9% of the cases, you're going to be distributing one function, multiplying it to the other function. Or, like this notation, it could say f times g of x. That means multiply the two functions together. Okay? And the last one is division. And so the first one is usually very obvious. This set of notation on the left, that's very obvious what they want you to do. The notations on the right, you might think, I don't know what I'm supposed to do. So whatever they're saying, add f to g, or subtract f minus g, or f times g, or f divided by g. Okay? It's just a shorter hand way of writing to add, subtract, multiply, or divide the two functions. So
you're not using it to solve. You're not solving. You're not, like, see how it says, actually, never mind.
Did you just answer your own question?
Yeah.
Okay, yeah. So first thing they'll do is they'll define what those functions are. This lesson, this section is substitution. It's all substitution. Okay? So you have to just do what they ask you to do. They tell you that f of x is equal to 3 of x. And they tell you that g of x is equal to x minus 5. So you have to find the following. First, we have to add the two functions together. So we replace f of x with what it is, what they told us that it is. So f of x is 3x. So this is 3x plus, and then whatever g of x is. Well, g of x is, it's x minus 5. Okay? That's 3x plus x minus 5. And then when you're adding and subtracting, all you're going to be doing is basically combining your like terms. Okay, so we just have to simplify that. So this is just 3x plus x minus 5. So that's 4x minus 5. So that is your answer. Okay? It is. And so this section is simple. But students tend to complicate it in their mind. So just think this is a section of substitution, okay? And so number 2 is f of x minus g of x, all right? So f of x is 3x minus g of x is x minus 5. When you're subtracting functions, before you combine your like terms, you need to make sure, because this is minus whatever this is, it's going to change the signs of whatever that is. Because it's like distributing a negative 1. Okay? And so this is 3x minus x plus 5. So that's 2x plus 5. Okay? So the addition is simple. Okay? The subtraction, you need to make sure whatever function you're subtracting, but it's going to change the signs of everything in that function. Okay? And you also need to be careful if it says g of x minus f of x, that you substitute in the right function where it belongs. Okay? Any questions? Yes.
It would still stay the same for both of them.
Could you do what?
You know how it says cos x minus 5? You could still do use the plus and it would still stay the same.
Yeah. When it's addition, you don't need to put the parentheses. I just did so that you see that I'm taking the whole function plus the whole function, so that when we went to the subtraction, you could see that you needed to change the sign to the second function. Yes,
How'd you get that extra X on the second thing? No, down.
right here. I just removed the parentheses, so it's 3x plus x minus 5.
That's what you have to do.
Yes,
Next subtraction, you just distribute
the -1, yes. Okay? Because it's like this whole function minus that whole function.
So when you multiply it, it just.
So we're going to do that. Okay? So this one says f of x times g of x. Okay? So you need to go back and see what was f of x. Well, it was 3x. So this is 3x times what g of x is. G of x is x minus 5. So it's times x minus 5. So you're multiplying those two functions together. Okay? And so now we need to distribute this 3x. So it's 3x squared minus 15x. And that's your answer. Okay, so we're just substituting in what f of x is and what g of x is, and then performing that operation. All right? And then number 4 is f of x divided by g of x. So f of x is 3x divided by g of x, which is x minus 5. And there's nothing I can do with that.
So,
So
like,
you leave it like that. Okay. Now, I showed you how to add, subtract, multiply, and divide two functions. Now, this is called function composition. Okay? When you compose, it means you create, right? So, function composition creates a new function. Okay? Now, this is one that it's easy to get confused on. All right? So you're basically taking one function and putting it inside another function. All right? But it's still just using substitution. So before we actually get to the actual function composition, let's make sure we understand how to substitute values into a function. All right? So if you were given f of x equals 4x plus 2 and g of x equals x minus 3, and then it told you to find the following. All right? Let's make sure we understand what we're doing. So if we were asked to find f of 2, that means we substitute 2 for x in the f function, right? So that's equal to 4 times 2 plus 2, right? Which is 8 plus 2, which is 10. So f of 2 equals 10. Okay, we substituted in 2 for x. Whatever's inside this
that's
parenthesis,
what I was talking about.
whatever's inside this parentheses, you put in the place of x here. So we replaced x with 2 right here. So we replace x with 2 right here. Okay? And so let's do the g. G of -3. Well, in the g function, the letter on the outside tells you which one you have to use. So in the g function, I replace x with -3. So I'm going to replace x with -3 on the right-hand side. Think about it like it's an equation, right? And so that's -3 minus 3, which is -6.
Yeah.
Okay? Now, I can replace x with anything they tell me to replace it with. Not just the number, I can replace it with anything. I just have to do what they tell me to do. So they tell me to find f of z. Well, instead of 4 times x plus 2, it's 4 times z plus 2. That's f of z. If I had to find g of r, instead of x minus 3, it would be r minus 3. Okay? This is replacement, substitutions, all we're doing.
Okay, but we gotta explain why.
Because they want us to take this g function and they want us to replace x with r, so I did.
Oh.
That's it, okay?
I was confused.
Don't confuse yourself. It's just replacement, all
I have
right?
a question.
Yes.
So like, the F function, you would do 4x squared plus 2? And that would-
Yes, I'm gonna replace x with x squared. So instead of 4 times x plus 2, it's gonna be 4 times x squared plus 2.
Easy.
Okay? That's the answer. Replace and simplify, replace and simplify, okay? Now, g of x squared is what?
X squared
X.
minus 3.
Very good, x squared minus 3. Okay? We still just replacing x with whatever they tell us to. We're following directions. So we have to find f of x minus 7. I'm going to replace x with x minus 7. So I'm going to replace x with x minus 7. And then I simplify. Okay? Instead of x, it changed to x minus 7.
Why do you have to have this one?
Because it's 4 times x. So now it's not 4 times x anymore, it's 4 times x minus 7. So that we simplify that. So that's 4x minus 28 plus 2.
So the x in these equations are coefficients. There. Yeah, so we have to plug in.
46.
Yes, it's what you replace. So that's 4 times x, 4x minus 26. So do g of x minus 7.
So you multiply, right?
No, we replace, we
Yeah, I know
take,
that, but you still have to.
well, I don't know, it depends on what,
X minus 7, parentheses minus 3.
yes, that's not multiplication though.
But you have to shoot it together?
Then you, no, it's not times 3, it's minus 3. Write it out. Write it out and you'll see what you need to do. So instead of x, we put,
Minus 7 minus 3.
yes, x minus 7 minus 3. That's not times negative 3, that's minus 3. So that's x minus 7 minus 3, which is x minus 10.
Teachers and students,
How
please
you
work.
doing?
Okay, so this is called function composition, where you're basically creating a new function, all right? It's still simple substitution. That's all it is. So it's telling us to find, and this is red, f of g of x. Instead of f of x, it's f of g of x. Okay? So we're still using the same, let me go back up and write the f, we're still using the same f of x and g of x function. Okay, so the same f and g function. So they want us to find f of g of x. Okay, well, you look at the f function. So let's replace g of x with what it is. Okay, no, you don't multiply. This is not multiplying. It would say times, okay? So this is f of, what's g of x? X minus 3. Oh, we can do that, right? We just did that, okay? So you take g of x and you plug it in right here, and then in the f function, you change x to x minus 3. Okay, which is what we just did. So we change x to x minus 3. So that's 4 times x minus 3 plus 2. It was just one more step. It was, instead of above here, we said find f of x minus 7, right? We could do that. So here, they're just telling you f of g of x. So you take whatever g of x is and you plug it in right there for f. That's all that is.
Oh.
You see what I'm saying?
Oh.
And so now you just simplify it. So it's 4x minus 12 plus 2. So that's 4x minus 10. So f of g of x is 4x minus 10. Okay? Now, the other notation, remember I showed you 2 different kinds of notation they can ask you, right? This means it looks like fog. but it's f of g of x. This is the same thing as that. Okay, it's just a different way to notate it. It looks like it's not filled in. If this was filled in, then that would mean f times g.
Wait, so how do you solve this without any?
That's it. If there's
What's
no,
another function, x minus b?
because that's what g of x is.
How do you know that?
No.
Because they told us.
When?
In the very,
Okay.
in the very top, we're still using the same two functions.
Okay, I know it.
Okay, so I rewrote them down there so we could remember what they were.
Alright.
All right? So if this problem said find, it looks like fog, but it's f of, think about that being a O, like of, f of g of x. That's the same function composition. Okay? Do not mistake this for multiplication. If it says this, that means your f function times your g function. If this is a circle, that means f of g of x. Okay, so anytime I see this, I rewrite it like that so I don't get confused. So I know what to plug in. Yes?
I have a question. I went there.
This is another one. Given that f of x equals 4x plus 2 and g of x equals x minus 3, find g of f of x. Find g of f of x. So this g on the outside stays the same.
Put it in G in?
Well, now instead of f of x, I'm going to put what f of x is. I'm going to replace that with f of x. So what's f of x? 4x plus 2.
So you have x minus 3 on the outside.
So now, when I'm looking at my g function, instead of x minus 3, I'm going to put 4x plus 2 minus 3.
And you wouldn't multiply that because
No, you just taking 4x plus 2 and replacing it right there.
so it would be
So that's 4x plus 2 minus 3.
Okay, I'm stupid. Ooh.
Instead of x minus 3, it's 4x plus 2
Okay.
minus 3.
basically
And so that's 4x minus 1.
What about the square one?
A to B.
Okay, try these. So now, instead of in the f function, we're going to replace x with 4x squared. So that's 2 minus 4x squared. And I can't simplify that anymore, so it's just 2 minus 4x squared. Yeah. That's perfect. Negative 4x squared plus 2. That's actually better because it's...
Don't you have to put your x over?
Yeah, you usually go in descending order.
Hey, chicken shirt.
Okay. Number 2 is g of f of x. So that's g of, what's f of x? So that's g of 2 minus x.
But then
Not yet. Well, when I substitute it in. Now, in my g function, which is 4x squared, I have to replace x with 2 minus x. So that's 4 times 2 minus x squared. Okay. Now, this is what I said. 2 minus x squared is not 4 plus x squared.
Yeah.
Whoa, you are gonna confuse me to the.
Okay. How he killed a puppy. He said this is 4 times 4 plus x squared.
Oh, no.
That's how he killed a puppy.
Oh, okay.
Well, couldn't you just do that? And then-
You can't do that.
Wait, a puppy.
So you just do
Bring it
4
over.
times 2x minus 4.
okay.
So that's 4 times 2 minus x times 2 minus x.
And that's it?
You have to distribute.
Okay.
and simplify it.
So you get 8 minus 4x.
What?
4x.
Yes. So you get 8 minus 4x times 2 minus x.
Yeah, I have to.
Don't kill
Can we do
puppy.
number 6 on our own?
Y'all can do whatever you want on your own. So this is 16 minus 8x minus 8x plus 4x squared.
Yay.
So that's 16 minus 16x plus 4x squared.
Not simple. You told me this is simple.
Then you have to factor a 4.
No, we're not factoring. We're combining our like terms and leaving it.
Oh, I'm sorry.
Wait, can I write it back?
This is factored. If we factored, we'd go back to that. You just work your way backwards. We just distributed. We're not gonna factor. Okay, so let's go over number 1 and number 2 again. Okay, so like I said, if I'm gonna put 2 minus x somewhere, it better be in the place of the whole f of x. So here I have to find f of g of x. Well, g of x is 4x squared. So that's f of 4x squared. I know, I'm doing it again. Okay, so now I replace this with 4x squared. So instead of 2 minus x, it's 2 minus 4x squared. Okay, in number 2, I have to find g of f of x. So instead of f of x is replaced with 2 minus x. So g of 2 minus x. Now, in my g function, which is right here, I'm going to replace x with 2 minus x. So instead of there, it's going to be 4 times 2 minus x squared. So now I have to expand 2 minus x, because anything squared means that times itself. You can't just square each piece individually. Yes?
So what you're gonna have is, you're gonna have 2x 2 times, right, in parentheses?
So 4 times 2 minus x times 2 minus x.
Alright, when you distribute that 4 into both of those?
No, it's only saying 4 times this piece. And then you get that answer and multiply it times that piece.
So let's say you didn't break it up and you distributed the 4 early and then distributed it,
You can only distribute the 4 to what it's multiplied to. You can't distribute the 4 over here. It would have to have another times 4 times this. Yes.
I thought you did it on the
yeah, that's what I was talking about.
4 times 2 minus x.
You can't. You have an exponent right here.
So you have to,
That's watching over this and protecting it. You can't get in there. No, we kill puppies when we square each piece individually. Okay? So that's 8 minus x, 8 minus 4x. When I distribute the 4, it's 8 minus 4x, and then times 2 minus x. Okay, in chapter 6, we just did this. We just distributed this stuff. Okay? So now, first we distribute the 8. So that's 16. 8 times negative x is minus 8x. Now we distributed that. Now we distribute the negative 4x. So minus 8x, and negative 4x times negative x is positive 4x squared. Now, if you were checking your answer in the back of the book, they usually put them in descending order, according to your exponents. So this, I didn't combine yet. Very good. So it's 16 minus 16x plus 4x squared. Your answer might be written in descending order, where your 4x squared will be first, then minus 16x, then plus 16.
To be alive.
Okay?
So you combine the like terms and then put it in.
And then I put it in descending order, yes, starting with your highest exponent and working your way down. But make sure when you rearrange those things that you keep the signs, what they are. Okay? Okay, so now we have to find g of f of 3. Well, I don't know what I need to plug into my g function yet. I have to find f of 3 first. I have to know what that is first. So f of 3,
Is 2x minus 2 minus.
f of 3 is 2 minus 3, which is negative 1. So this is asking me f of 3 is negative 1. So find g of negative 1. So now I plug negative 1 in for x in my g function. So g of negative 1 is 4 times negative 1 squared.
Which is still 16.
No, it's not.
No.
It's 4.
We're not squaring 4, we're squaring negative 1. What's negative 1 squared? So that's 4 times positive 1, which is just 4. Yes. Order of operations. Okay? And for number 4, we replace g of x with what it is. It is 4x squared. So that's 4x squared minus. Then we replace f of x with what f of x is, which is 2 minus x. Okay? So this is 4x squared minus 2 plus x. But we're going to put that in the correct order for our final answer. So that's 4x squared plus x minus 2. Okay, and when you're doing adding, subtracting, multiplying, and dividing, it might make it easier just to make sure you put that whole function in parentheses. And then either add it to the next function in parentheses so that you make sure and don't mess up any signs. Okay? Any questions? Okay, for number 5, the directions are saying f of x times g of x. So f of x is 2 minus x. So it's 2 minus x times g of x, which is 4x squared. So that's multiplying. So that means we're going to distribute. What are we going to distribute? The 4x squared. So that's 4x squared times 2 is 8x squared. And then 4x squared times negative x is negative 4x to the third. And then I'm going to put it in the correct order. So negative 4x to the third plus 8x squared. Okay, so number 8 was g divided by f of x. So that's g of x divided by f of x, or you could put g of x over f of x. And what was g of x? 4x squared. And what's f of x? 2 minus x. Very good. Any questions? So you have, I think, only 8 problems out of your book to do. So do that in class, and then you'll just have your review to finish tonight before the test.